Hello guys and welcome to the second part of the Convert channel, Shell and Tube Thermal Design. Before watching this video, I highly recommended you to watch the previous video to find out how can we calculate number of tubes in a Shell and Tube heat exchanger. To just remember you what the problem was, just bring this page and you can note down all information and insert all the data into the Excel to uh, come with me step by step. So before calculating velocity, we need to say and actually calculate something first. We need uh, density and internal diameter of the tube. For density, we need to select this cell, which is the specific gravity, and multiply this number by 62.4. This is the 62.4 is the density for the water into the British unit, and repeat this for the for this cell as well for the oil which passes through the tubes. So for the internal diameter of the tubes, we need to find out what is the diameter of the tubes of the 1 inch and 40 BWG. So let's get back to the tube ID gauge, which is 40 BWG and 1 inch as the outside diameter. By intersection of these two numbers, we have this number. So insert this number into the Excel, 0.834, and we need this internal diameter of tubes into the foot unit because we are going to calculate velocity into the foot per second. Just press equal and insert the convert command, open the bracket and select the cell which you want to change its unit from the inch unit into the foot unit. Close the bracket, press enter. So we have the internal diameter of the tube in the foot. And at the second part, we am going to calculate velocity per number of passes, and by taking, for example, a specific number of passes and multiplying this number of passes by this cell, we can calculate velocity. If the velocity is within the range, we select that number of passes as the selected number of passes, and by knowing number of passes and number of tubes, we can calculate internal diameter of the shell site. So let's check that out. How can we calculate? Just press equal. We have the formula right here. Open the bracket, insert 4 and multiply this number by 150,000 pound per hour, which is given into the problem, 150,000 pound per hour, and divide this number by the density of the oil which is passes through the tubes. Just make sure that you have opened the bracket and insert density after that. Multiply this number by the pi number, again multiply by the number of tubes. Select this cell and multiply this by the internal diameter that we determined just right here. Multiply that 2 times, close the bracket, and divide this number by 3600 to change its unit from the hour into the second, because we need the velocity into the second unit. Press enter. We have the velocity per number of passes. So I'm going to, for example, take 6 passes as the number of passes of the tube in the shell and tube. And now we can calculate velocity as well by multiplying these two numbers, and we take 6 passes. So as you can watch, the velocity is within the range, and actually it's near at the high end of the recommended velocity, which is acceptable, I think. So I'm going to take 6 passes and 155 as the number of tubes for calculating shell internal diameter. For the tube count table, we have the thema S or P and thema U. Because our oil site have a high tendency for fouling resistance, we are going to select thema S and number of passes. We select 6 passes and the number of tubes that we calculated is 155, which is near to this number. By intersection of these two numbers, we have the shell ID of the 21 in inch unit. So you can, for example, change this and see what is going to happen by changing number of passes and calculate all this number by yourself. So I hope you enjoy this video as well. And at the third part, I'm going to calculate all this number using HDRI software as well and optimize all these parameter into the software. So thank you guys. Have a good time. Bye bye.